Okay, so June 2017, I'm going to write on the answer sheet just to make it easier. And if you just scroll back up, you'll see the questions. Stop the video, etc. if you need to, or have it printed off before you. So the first question asked for the forces. This is in equilibrium. It's got the angle there, 5 kilogram, and it asked for the normal force diagram acting on the block. It said it's in equilibrium, but it was on a rough plane. So you're going to have friction going this way, you're going to have your normal reaction that way, and you're going to have your weight down here. Okay, so that's the first part. It then says the normal reaction is 37.5 newtons. So here I would have, that would be lambda there, so I'd have 5 cos lambda. So find the frictional force. Okay, so first of all we need to work out what the angle is to be able to do this, although it does help you with that. So 5 cos alpha equals 37.5, so cos, mg, I haven't put mg, have I? So 5g, so times 9.8, sorry. So equals 37.5 over 5 times 9.8, and you should get that the angle is 40.0657, which is 40 degrees. So I've found the angle, but it wanted me to find the frictional force as well. So resolving this way, we've got 5g sine the angle. So part 2, I've got 5g sine 40 equals F, and I should get that is 31.5 newtons. Okay, question 2. Part 1. It's a bird flying a vertical plane. It's got the position vector r and it wants the velocity. So we've got r equals 0.8 plus 2 minus 4t plus 0.1 t squared. Can you see how this is like just s equals ut plus a half a t squared, and it's actually at some point up in the air. So to find the velocity, we just do dr by dt. That just disappears, so we get 2 minus 4, and we get plus 2 0.1 t. So you end up with 2 minus 4 plus 0.2 t, and you just leave it like that. So part 2, it's then it says find the velocity when t equals 2.5. Sorry, I haven't finished. So when t equals 2.5, dr by dt equals 2 minus 4 plus 0.2 times 2.5, which is 2 minus 4 plus 0.5. Okay, that's just the position vector of it, but obviously we need to actually resolve that. So I've got 2 in the I direction and 1 in the j direction. So if I then draw myself a diagram, I've got 2 and 1, so by Pythagoras that becomes the square root of 5. So my velocity is the square root of 5 meters per second. Okay, part 2, it says find the time at which the speed of the bird is 10 meters per second. So I'm literally going to put 10 equals 2 minus 4 plus 0.2 t. Okay, so what have I actually got? I've got thinking of it like this. You can still, even though it's servos, you can still think of it like this. So I've got 10, I've got 2 on the one direction, and minus 4 plus 2t in this direction. So using Pythagoras, I get 10 squared equals 2 squared plus minus 4 plus 2t all squared. So 100 equals 4 plus, I get 16 minus 8t minus 8t minus 16t plus 4t squared. Okay, so 0 equals, so that becomes 20, so I get minus 80 minus 16t plus 4t squared. Divide through by 4, I get minus 20 minus 4t plus t squared. Okay, don't think it factorises, so I'm just going to complete the square. T minus 2 all squared, so I need to take off 4, take off 20 equals 0. T minus 2 all squared equals 24. T equals 2 plus the square root of 24, or 2 minus the square root of 24. That's obviously going to not work because time has got to be positive. So you should get that t equals 6.9 seconds. Okay, part 3, find the times at which the bird is flying at an angle of 45 degrees to the horizontal. Now I really had to think about this, but the clue is that it's 45 degrees. So actually what you've got is you have got actually a equilateral triangle. So if you just look at the one above it, what you've got is that they're the same. So t must be the same as minus 4 plus 2t. But you just have to think about it because it's sort of the modulus, okay, and whatever they are squared, the double of it, you're actually going to have 2 or minus 2 because it could be going the other way. So you've got either 2 equals minus 4 plus 2t, because we'd complete the Pythagoras thing and it would have just come out that both sides are the same. So you've got 6 equals 2t, so t equals 3, or minus 2 equals minus 4 plus 2t, so you get 2 equals 2t, is that right? Yeah, and so t equals 1. Okay. Right. Question 3. Okay, Olga and Petya are using light ropes to pull the sledge across the snow. The sledge has got an acceleration of 0.05 metres per second in the direction of its line of motion. Find the frictional force acting on the sledge. Okay. It says... Okay. So what we've got is 430 kilograms. We've got Olga. We've got Petya, I think that's how you say it. 20 degrees. 20 degrees. And that's the direction that they are looking at. We've got a frictional force obviously going the other way. The overall system, I've got A being 0.05. Okay, so using Newton's second law, F equals ma. Okay, the overall thing that I've got is, that's my frictional force. Resistance or thing. So the whole thing is in this direction. I've got that 2 times. They're pulling with 120 newtons. 120 newtons. 120 cos 20 minus that frictional force must be the overall mass times acceleration, Newton's second law, which is 430 times by 0.05. Okay, and so you'll get 240 cos 20. Take this to the other side, you'll get minus 21.5. Take the friction to the other side, and you'll get that. And you should get that it's equal to 204.026, which makes it 204 newtons. Okay, they now change to walking side by side. Their ropes are still horizontal and are now along the line of motion of the sledge. They maintain their forces 120 and the frictional force remains the same. Find the percentage increase in the acceleration of the sledge. So we're going to use this 204 newtons then. Okay, so we've got 204 newtons there, but now we've just got them 120 newtons each, and it's still 430 kilograms. So the overall thing, so we've got two lots of 120 minus 204 equals mass times acceleration, so 430 times A. So you get 240 minus 204 equals 430A. I think that becomes 36 over 430 equals A. So you should get A equals 0.0837. But just be careful because it said find the percentage increase. So it was originally 0.05. So 0.0837 minus 0.05, that's our increase, over 0.05 times 100, and our percentage increase equals 67.4%.